Hi, this is an introduction to logic. I'm Mark Thorsby, and this course overviews the basics of categorical, propositional, and predicate logic. Today we're going to be looking at today we're going to be starting propositional logic, and in particular we're going to be talking about the basic symbols of propositional logic and how those symbols can be used to translate ordinary language arguments. Okay, welcome back, everyone. What I want to do today is sort of start off because what we're doing is um, in our last couple of videos here, we were looking at categorical logic, and today we're starting a completely new system of logic called propositional logic. Um, and you can basically understand, in order to explain what propositional logic is, let me start off by taking a look by reviewing what categorical logic was. You'll recall that in categorical logic, what was the basic unit, right? The basic unit that we used in categorical logic, right, were categories. And that each of these categories it can be found as a specific sort of term, right? You remember in categorical logic, for instance, we have lots of things, propositions that take the form all S or P and so on and so forth, right? Um, And what that means is that each one of these, the S, whatever stands for the S and whatever stands for the P, these are both categories, right? And the terms are the basic units. Now, as a result, we only had four types of propositions, right? We had the A, the E, the I, and the O, or the universal affirmative, the universal negative, the particular affirmative, and the particular negative, right? So that was the only four types of propositions we really ever looked at. And when we did our work in terms of translating ordinary language arguments into categorical logic, it felt very forced, if you will, right? Because as we were translating it, people don't talk like this. People don't say no S or P, right? People don't use that language, right? So what we're going to see in the propositional logic, which by the way is a system of logic that comes much, much later, right? We mentioned that categorical logic, it originates from Aristotle's sort of investigation of human reasoning. Propositional logic comes centuries and centuries later. In fact, with really the work of Leibniz. In fact, your textbook has a little sort of piece on Leibniz. In our extra credit series on the history of the development of logic, we have a whole session devoted to talk about Leibniz. And remember, Leibniz, he was also the originator of contemporary calculus. The form of Newton also invented calculus, but Leibniz, the form of calculus we actually learn in our high schools, is the form that was invented or discovered, if you will, by Leibniz. So propositional logic comes much later. Now, what exactly is the basic unit of propositional logic? Well, the answer is quite simple. It is a proposition, right? Now, if you recall, what's the difference between a proposition and a statement? So propositions versus statements. And in fact, I think in an earlier video I actually covered this, but a statement actually refers to the sort of wording, the phrasing, if you will, that people give when they make arguments, right? This is sort of has to do with the sort of grammar that people use. Whereas the proposition isn't referred to the wording, it refers to the meaning of a claim, right? And so an argument has multiple propositions. And what we're going to see is that the basic unit, instead of saying that each individual terms, right, as for instance, we said that each one of these terms is the unit in categorical logic, the entire proposition is going to get symbolized by capital letters, right? In any capital letter, it doesn't matter what capital letter it is, right? So what we're going to do is this allows us to have really a fabulously rich tool to analyze ordinary language arguments in terms of determining whether or not they're valid or invalid. Um, and um, and so that's really key because it means that instead of trying to force an ordinary language argument into categorical form for analysis, we can now really just take a look at the proposition, assign it a variable, and what we're going to introduce is what we call connectives to relate different propositions together, right? And so this is the basic unit are propositions. And so this is sort of the beginning of what propositional logic is. You're going to see that what we're learning now is going to carry on over into our study of natural deduction and also into our study of predicate logic. Predicate logic is not quite the same as propositional logic, but very, very close. So that's a sort of basic overview of what propositional logic is. So each proposition gets put into a capital letter, and if you have multiple propositions in an argument, they have to connect in some way, right? So let's sort of give an example. What if I said, George is a clown, and George likes kids, right? What about if I make kids, right? So what if I found someone say something like this? This is a sort of ordinary language argument. Someone says, George is a clown and he likes little kids, right? How would I symbolize this, right? Well, here's what's important, and what I'm trying to do is talk about the connectives, right? Here we have George is a clown. This would actually consider be a first proposition, and George likes kids would be a second proposition. And this term here, this is what we call in propositional logic a connective or a logical operator, right? This and is going to be called either a connective, right? And mainly I want you to think, instead of thinking of a connective, think of it as a logical operator. Okay. Now, what gets connected? Well, these two different propositions. And so I could actually symbolize this statement here as G for George is a clown, right? And you're going to see I put a little dot here to symbolize the connective, the and then George likes kids, we'll just put a K here, right? So this G and K symbolizes this whole statement. Now, this is very, very rough at this point. So what I'm going to do now is I want to go through and explain to you what each of the connectives are and show you what they mean, and then we're going to sort of take a look at the textbook in this section and we'll give you examples on how ultimately to translate ordinary language claims into propositional form, okay? So let me scroll down here, symbols and translations. What I want to do here is I want to start off by talking about what are the different operators, right? What are the different operators? The first operator here is what we call negation. Negation. Negation, and what's the symbol we use? The symbol we're going to use, and by the way, there are actually many different types of symbols that you could use, and in fact, different logic texts use different forms of symbolism. We're just going to stick with the symbolism that's located in the Hurley book, which is the same sort of symbolism that in fact got used in Bertrand Russell's Principia Mathematica. So it's a very famous form of symbolism, but in fact most probably predicate logicians today probably don't use these symbols, but it doesn't really matter because ultimately whatever symbol we use, the rules are going to be the same. So we have a negation. We're going to symbolize that by a little squiggly line. In fact, if you look at your keyboard, it's right underneath the escape key, right? It's a little squiggly line. And this is called a tilde. That's what we actually call this thing, right? And so what is the function of this? It is to negate, right? It is to negate, right? And what are some of the words that get used? For instance, you could use the word not. Not is the typical one, or it is not the case that, etc., etc. And I'm going to show you examples of that in a minute. So the first one is negation, right? So let me just run through them actually here. After negation, we have conjunction. Oops. Conjunction. And conjunction is symbolized with just a little dot right in the very center. Not a period, but a little dot. And the function is to combine. Right, conjunction, right, and that's the logical operator, the connective I used up here when we looked at G and K, right? That was what's called a conjunction. You can remember it because in a conjunction, you're conjoining or you're combining two different propositions together, right? The most typical word here is going to be and, right? also, moreover, even in some cases the word but actually means a conjunction. And we're going to see that even though propositional logic gives us a fabulous tool that I think is better than categorical logic, it still is not going to be completely sufficient to translate all of the things we do in human language. So anyway, let's move here to the next one. After conjunction is what we call disjunction. And we're going to symbolize that with a little v, a lowercase v, and we're going to call this the wedge. Right? And what the wedge does, it basically says it's an either or. Right? Usually the word we're looking for here is or. So if I say, for instance, imagine if I said, George is a clown or George is not a clown. Right? So how would I symbolize that? Well, maybe that's a little confusing at this point. But if I said George is a clown, I could put just a G. And I put or George is not a clown, I put negation G. Does that make sense? Right? So either George is a clown or George is not a clown, right? The not gets put in front of the G, okay? So let me go actually. Let's erase that. Okay. And I'm going to give you examples for all of these as we go. There's disjunction. The next one here is not disjunction, but rather implication. I'm going to probably in most of the videos refer to this as a conditional. And the conditional here, the symbol we're going to use is basically it looks like a horseshoe. It's sort of this weird symbol. And you'll see that one of the things you can do, since this is an online class, if you're using your computer, if you're using Microsoft Word, you can actually get all of these symbols by just clicking insert and you find the symbol and then you can give it a keystroke and you can use these fairly easily. But the implication, the conditional. Now, the conditional is basically any sort of if-then statement, right? So for instance, if I said that, let's give an example here. I'm going to change the color. What if I said, if George eats cotton candy, then George will get sick. Right? So how would I symbolize this statement? If George eats cotton candy, then George will get sick, right? And when you'll see that immediately, what I can see is since I have any statement that has an if, then in it, basically that tells me that I need to be using this conditional right here, right? Now, remember, the difference here is, and you can see perfectly here that this whole thing here is a statement, but the statement contains two different propositions and two different moments of meaning. This would be the first sort of proposition. George eats cotton candy. So let's symbolize that with C. And George will get sick. We can symbolize that as an S. And so what this will look like is it will just like C, conditional, S. Right? If George eats cotton candy, then George will get sick. Right? Very simple. Now, one of the things that's worth reminding everyone, and I think we actually did cover this in our last chapter, but it's more important actually now that we're doing propositional logic, is to remember what each of these positions on a conditional is called. Hopefully you can maybe pause the video and ask yourself, do I remember what they are? If you do, what you'll remember is that this is called the antecedent, and this one is called the consequent. And it's easy to remember these. Here, I'll move the arrow. It's easy to remember these because the consequent is always what follows. It's the consequence of the condition, okay? And you can see here, and the reason we call this the implication operator is because this is going to imply this, right? So if this is true, if this condition is a true condition, if you get C, then it's implied, or you can imply that S will take place. So this is the antecedent, and this is the consequent, right? Now, sometimes this is called, and what this means is that it's also referred to as a material conditional. I should tell you that too. I'm mainly just going to call it conditional, but sometimes it's referred to as a material conditional, or at least this statement here is a material conditional, and this thing here is the operator, the implication operator, right? So you'll see that sometimes, especially if you're looking on YouTube and you're taking a look at other videos and you're sort of looking around, sometimes the language will be a little bit different with different logicians, but this is basically the function, the same function for all of these. Okay, we only have one more after implication, so I'll switch back to red, and that's what's called equivalence. And equivalence is symbolized by a triple bar, right? Not the equal symbol, but a triple bar. And what this really means is it means if and only if. Or in other words, what we're talking about is a sufficient and necessary condition, right? So the triple bar here is the operator of the equivalence here is very similar to the conditional, because remember, this is an if-then. The triple bar means that if and only if, right, you have two conditions. So let me give you an example. Or we can go back up here. What if this said, George will get sick if and only if he eats cotton candy, right? We could turn that around, right? So if I said that George gets sick if and only if he eats candy, I can just literally write S, if and only if, C in this case, right? So George will get sick if and only if he eats cotton candy. And what's interesting here is it actually doesn't matter which side these two things go on. Because if I say George eats cotton, well, no, it does matter actually. But we'll see that in terms of their truth functionality, it doesn't matter what side they're on in terms of the triple bar, because they are what? They are equivalent, right? And this is sometimes referred to as the material equivalence. The material equivalence, right? And it basically means if and only if. Okay, so you have the triple bar. Now let me sort of show you, let's go down here, and here's a very much nicer sort of thing to take a look at in terms of here's the operators, here are the names, here's the functions, and here's the basic words you use to translate these things, right? One of the things you'll notice here is that all of these, the dot, the wedge, the horseshoe, and the triple bar, all of these here require two propositions. Whereas this one up here, this only needs one proposition, right? This only needs one proposition, right? And so that's really important. So if you ever use it, you can never have like a just something like that. George eats cotton candy and what, right? You always have to supply a second proposition here, right? So that's a sort of important feature, because one of the things that we're going to need to talk about here is ultimately, and we'll see as we go through these, we're going to have to learn how to really build up very complicated arguments, because a long argument has many propositions and has many different types of connectives. So what we're going to have to do here, and we're going to do this sort of at the end of the video, is talk about how to figure out what the main operator is versus the main operator of a large propositional statement, and how do you figure out the main operators, because that's really key. So let me make one more distinction that your book talks about that's actually pretty important for us, right? And that's basically the difference between simple statements, right, and compound statements. And we have actually already covered this in this video already, but I just want to sort of lay it out here, the wording, right? When I say that these require two propositions, what I really mean is that these operators always exist when you have compound statements, when you're combining statements together, whereas the tilde here, it only needs one, which means that you can just have a simple statement, right? Most of everything we're going to do are compound statements. So it's not really too big of a deal, but since your book does talk about it, I thought it important to at least mention it. Okay, so let's give an example here. Let's do a quick examples of some translation examples. Okay, what about this? And you can see here that instead of giving propositions, we've just put down letters. It is not the case that A. Now, one of the things you might want to do as you're watching this video is to pause it and try to write these out and then see if you did it right. it is not the case that A, this is going to be translated as not A, okay? What about this one? D and C. This is going to get translated D dot C. What about either P or E? Either P or E, right? That you're going to use disjunction, your little V, or E. P or E, okay? What about if N, then F? If N, then F. Here, I'll write on this side. It's going to be N, right, horseshoe F. B, if and only if R, right, is going to be B, 1, 2, 3, R, right? So you can see here, this is the basic sort of way that you're going to have to learn to use these operators and build compound statements, okay? Now, one thing I should mention before we get going, and I'll probably mention it again in another video, I imagine, is the disjunction. Now, you may not be thinking this since you're just watching this video at this moment, but a question may occur to you. If I say either P or E, that usually means this one or this one, but not both, right? So there's actually two types of disjunction. There's what we call inclusive disjunction, and there's also exclusive disjunction, right? Normally, when we say either or, for instance, if I say either it's going to rain or it's not, right? That's an exclusive disjunction. It means either this or this, but not both. Whereas what we're going to see just to make things easier in this course, since this is an introduction to logic course, we're only going to use the inclusive disjunction, which means that we mean either A or B or both, right? Which means that when I say that the way we're going to translate it, when anyone says either P or E, we're going to say that means that either P is the case, E is the case, or both of them's the case. And we'll probably talk about that a lot more actually in the next video, but I at least want to lay those cards on the table for you right now, because that may be a question that's sort of popping up in the back of your head. Okay, so what I want to do now is I want to sort of take a quick tour of your textbook here, because your textbook gives some nice examples here that we might as well take a look at. After all, you bought the thing. We might as well take a look at in order to see some of the ways in which the translation issues that come up, because we have to translate, as you can see, they put in scare quotes there. Okay. As you can see, we already did that. Let's move down here, right? Take a look at this, right? Rolex does not make computers. You can see that's not R. It is not the case that Rolex makes computers. That's also not R. It is false that Rolex makes computers. That's also not R. So you can see here, this is the difference between statements and propositions, right? All of these are different, but they mean the same thing, right? So that's the first thing. And you're always going to place the tilde in front, never behind a proposition, right? So let's take a look at this complex proposition. G and not H, and not G. I didn't mention parentheses, so let's talk about that. Let me give you an example here. Let's start with this. G and not H. Let me scroll down here. So what happens if you have G and not H? Right, this could mean, for instance, George is a clown and he doesn't like to wear hats or something like that, right? So that's, for instance, what this could mean. Now here's a question. What's the main operator? Right? Because one of the things that's going to be critical, and you're not going to really see it in this chapter, but in the next chapter you're going to see this, and it's going to be critical throughout, that you can identify the main operator. How can you figure out what the main operator is? The main operator in this case, because you see here we have two different operators, right? We have the conjunction and we have the negation. Which one is the primary operator that we're concerned with? Ultimately, you want to think that the main operator is the top level operator, right? And in this case, it is the conjunction, right? Because remember, the negation only refers to this, but this thing is talking, or actually connects these two things together, which means that this is the main operator, right? Let's give another example. What if I say not G and H? right? I say it's not the case that George is a clown and he likes hats or something like that, right? What's the main operator in this case? Is it the conjunction? You can see here we did something new that we haven't done yet in this video. We introduced parentheses. And you can see we actually use parentheses, brackets, and these little squiggly things. They're all on your keyboard. They all operate the same way. We're just going to call these parentheses, right? So what do these things do? Well, remember, every operator, all of our operators that create compounds always require two things, right? So let's imagine, for instance, if I put G and H and W, right? This is actually very bad, but what's the problem with this? The problem with this statement is because the operators, and this is a feature of categorical logic, because the operators always require two propositions, and I really should wrote they require two and only two propositions, then that means there's an issue here, right? Because here I don't know, am I saying G and H or am I saying H and W? And then of course, what's the relationship between G and W here? You can see it's sort of confusing here. So what's really critical is we use parentheses, right, to make sense of it, just in the same way you use parentheses in algebra, right? So this now tells me that the H and the W are what get combined, and that the G is actually being combined with the whole thing, right? Whereas you could even symbolize this with the new symbol. So this would be G and X, really, where X is really stands in as a symbol, as a variable for H and W. Right? So if I and what's the main operator in this one? Well, remember, this is why I want to use the top level operator, meaning it is not buried in parentheses within the argument. So the top level operator here is this conditional. This is the top level. I don't know why I circled that. Okay, so let's move over here. What about this guy right here? What's the top level operator? Well, the parentheses tell me that the G and the H are combined together, which tells me that the negation is actually applied to the entire thing. Right? Now, if that's the case, then this is the top level. This is the top level operator, or the main operator. Okay? And so that's really critically important. In fact, one of the standards that's going to be used in this book is a well-formed formula, I think is the way Hurley puts it. He calls it a WIF, a WFF. What is a well-formed formula? It's a formula that doesn't confuse where the operators are related. So for instance, let's take a look at this. What if I put A and C if and only if B, right? You can just you can see here, we have a tremendous versatility, or T. Right? So you can see here, how do I understand how the parentheses work in this case? Right? Well, the parentheses here tell me, you can see here that the reason I sort of use the top lever is that that in the very middle there is the C if and only if B, and then beyond that, right? So these two things are combined here, and then this thing is applied to this entire phrase, right? And then this whole thing counts as one part of the disjunction for the T, which means that this right here is the main operator. Now, as soon as you understand what the main operator is, it actually allows you the ability to understand, and ultimately to translate these statements, you have to understand what the main operator is, because you have to figure out what is the main thing, the main connection between all of the different propositions that are being said in a statement, right? And one of the things you have to watch out not to have what we call non-WIFs, right? Or not well-formed formulas, right? Those would be formulas that confuse what gets related to what. Right here, I gotta fix that. Okay, let me give you an example of a bad one, a bad example. This would be A if and only if B or T or J. Right? Okay, here's an example. This is bad. This is a no-no. Bad, bad. You don't want to do this. What's the problem here? You can see the problem here is, wait a second. This is relating to this, and this is relating to this, but how are they right? Because remember, the rule is that every operator should only relate to basic propositions together. Parentheses allow us to combine them and sort of like Russian dolls, squeeze them in. But you can see here, this doesn't make any sense because I could just boil this down. This basically looks like A, if and only if X or J, right? There's no main operator because it's working on too many. So this is not a well-formed formula. And if we wanted to make it a well-formed formula, it's very simple. All we have to do is actually add brackets, right? Now, parentheses and brackets and the squigglies all work the same, except you just want to sort of, the reason we use parentheses and then we use brackets and then we use the squigglies and then we just start over is we do that so that way it's easier to see visually what is getting nested within what, okay? So that means that the main operator here is the biconditional, or the material equivalence. I forgot to mention that. We also call the exclusive here, not the exclusive, we also call this if and only if, besides calling it, actually let me just scroll up here. Besides calling it the equivalence, I'm going to typically also refer to this as the biconditional. Okay, so that's sort of an important thing to talk about. Okay, so you have to be able to diagnose these. What is a well-formed formula and what's not? Okay, well, let's go back to the book here. Sorry, I sort of got off on a little tangent there, but at least now you can see what the difference between these two things are, right? And you can see here, these are negations, not B. This is not G, therefore H. And you have to get used to using these, no, I'm sorry, not G. It's not the case that if G, then H is what this says. And what does this say? This says, it is not the case that A, if and only if F, and C, if and only if G, right? So this thing gets applied to this entire statement, not to any one particular, but to all of them combined. In fact, it gets technically combined to it gets applied technically to the conditional, okay? You can see here, here's where they start talking about main operators. I'll scroll down since we sort of already covered it. Let's take a look at what some of the examples they give for conjunctions, right? So here's a conjunction. We have a C and not L. You can see here, because the negation only operates on one variable, the variable that directly follows the negation, you don't need parentheses here. Right? You don't have to put this in parentheses because everyone knows that this can only apply to what follows right after it. Okay, and it never goes backwards. It doesn't apply to what's in front of it, only to what's after it. So here's another example. This would be an E or F and not G or H, right? And you can see they can get very complicated, right? So here you go. Here's parentheses and here's the brackets, right? What's the main operator in this phrase? Right? You may have initially thought this, but because of the brackets, that's not the case, right? We have two brackets, which means that the main operator must be this conjunction. Okay, let's scroll down here. The disjunction, and you can sort of take a look at these, but I'm hoping that my explanations here are helping. This is not C or not D, and here we have what's the main operator. It's the disjunction here. And I'm just going to tell you right now, for those of you who are seeing this for the very first time, this is going to seem like a lot of new symbols you have to learn. And it is true. You're just going to have to memorize these and get used to them. Fortunately, the homework that's included is really meant merely to give you practice. And that's why the homework is so important to do. Even if your instructor doesn't give you lots of homework, I encourage you to do all the homework. Why? Because the more practice you do, the more familiar and the more comfortable and the better you'll do with these things. Because you just have to learn to get used to these, right? So for instance, what's the main operator here? The disjunction. What's the main operator here? The negation, okay? So let's scroll down here. You can see these are conditionals, the material implications. Basically, this is if H, then not J, right? If you wear a hat, then it's not the case that you're going to become jaded or something like that. A or C, what's the main operator here? It's the material implication, the conditional. And what about this one? That's right, it's the material conditional. I'm hoping you actually saw it. Now, one thing is, remember here, in the very first chapter, and I encourage you to go back and take a look at it, we talked about the difference between sufficient and necessary conditions, right? This conditional can translate either one, and it can get kind of confusing here, right? So I want to actually draw your attention to this, because a lot of people get very confused with how do you translate necessary and sufficient conditions. Remember, a necessary condition is a condition that has to be met in order for the consequent to occur, um, but it may not be enough, right? The sufficient condition must be, I'm sorry, the sufficient condition is enough for the consequent to occur. So think about it like this way. Um, if I put gas in my car, then I can drive, right? Putting gas in your car is a necessary condition for driving, but it's not sufficient in itself because in order to drive, you have to also have a driver's license and you have to have oil in your car and you have to have tires and so on and so forth, right? So putting gas in your car is a necessary condition for driving, but it's not a sufficient condition. So let's take a look at this, right? And I'm going to read this because it can get a little confusing, but I think it's helpful, right? So to translate statements involving sufficient and necessary conditions into symbolic form, what you need to do is you need to place the statement that names the sufficient condition in the antecedent of the conditional, right? Remember, the antecedent is what comes first, and the consequent is what comes last, right? So sufficient conditions, again, go in the first part, right? Let me keep reading this. Place the statement that names the sufficient condition in the antecedent of the conditional, and the statement that names the necessary condition in the consequent, right? And so he has this mnemonic device to help you, and he says son because that's the horseshoe sideways, right? So son. So whenever someone says, for instance, it is in order for you to get a job, it is a sufficient condition that you have X, Y, and Z experience, right? So where do you put the sufficient condition? You're going to put that in the first part. If someone names a necessary condition, you're going to put it in the consequent position. So this is really, really important because otherwise you're going to get these things confused, right? Because whatever is given as sufficient condition in the place of the S and whatever is given as necessary condition goes in the place of the N, right? So here's some examples they give, right? Hilton's opening a new hotel is a sufficient condition for Marriott's doing so. Well, okay, if this is the sufficient condition, then it must go on the front. H, if Hilton does it, then Marriott's going to do it. What if they say it's Hilton's opening a new hotel is a necessary condition for Marriott's doing so? Now think about it. This is where you can start, once we actually look at the example, it starts to make a little sense here. Because Hilton is only going to open the hotel if Marriott does it, which means that what has to take place first is not Hilton, but Marriott. Right? So the Marriott must be the antecedent, and the Hilton following suit must be the consequent. Okay, so this hopefully is an example that really helps clarify why that's the case, because Hilton isn't going to do it unless Marriott does it first. Right? That's basically what it comes down to. So whenever you have necessary conditions, what that means is that something has to occur first before the necessary condition gets met. Okay, and that's the way to understand that. And then finally we have the triple bar, right? Or the biconditional. You can see here it goes. The material equivalence, the triple bar, right? Here's what it takes a look at. Okay, here's an interesting. What's the main operator for this phrase? It's not the case that B or D, if and only if, it's not the case that A and C, right? Many of you may be inclined to say that's it, simply because it comes first. But remember, this negation only applies to this, what's in the parentheses that directly follow it, which means that the main operator is actually this biconditional, okay? And here, what I want to sort of show you, this sort of thing talks about, we have to be careful where we put our parentheses and our brackets, okay? And sort of the language of how we use words like either and both and things like this can actually change the meaning of how we're going to symbolize it. So what I'm going to ask you to do is, as you go through the translation exercises, and you really should just do all of them, whether they're assigned to you or not, just so you can get a handle on it. Because if you don't get a handle on this, it's going to become very problematic as we continue the course. What you need to do is you need to always ask yourself, what's the takeaway? What is it that this person saying this wants me to understand? And then once you can sort of get in your head what the proposition is, then you symbolize it, right? Don't just assume that because you see the word and or that that's the way it actually gets written out. Now, this one you can see here. Let's just run through a couple of these examples. Prozac relieves depression. Allegra combats allergies, or Zocor lowers cholesterol, right? So the question is, where do we put the parentheses? Well, in this case, because of that comma, that really tells us that the and here was trying to combine these two things. So we'd symbolize it like this, right? With the parentheses P and A, close parentheses, or Z. Now, what about this one here? It's just that the parentheses have moved, so that's going to change what we do, right? I'm sorry, the comma got moved. So Prozac relieves depression, and Allegra combats allergies, or Zocor lowers cholesterol. Because of the movement of this comma, we're going to move our parentheses around and say that, well, that comma means that this thing must be a separate proposition. And that's something to consider. Take a look at this last one. I don't want to do all these because you can read them on your own. If Merck changes its logo, comma, then if Pfizer increases sales, comma, then Lilly will reorganize, right? How should you do this one, right? Well, this if, and then this then tells us that these three propositions get combined with conditionals. And what we have here is we basically just follow along things, right? If and happens, then it's the case, open parentheses, if P, then L, right? So this one was a little bit confusing, but it's not really too difficult. You just think about what's the takeaway, what's the basic meaning that's trying to be said here. And you can see they're going to give you even more complicated examples like this. If Schering and Pfizer lower prices, or Novartis downsizes, then Warner will expand production, right? So you can see here, sort of start with if Pfizer and Schering and Pfizer, that and tells us that they're talking about these two things, right? So we can place them right here. But then this if means that at some point we need a conditional, but we're not sure where it went. So Schering and Pfizer lower prices, or Nordis downsizes. So you can see this must be combined here. You know, open and close brackets, so that counts as one thing. And then since this is the if, this becomes the antecedent, the horseshoe or conditional. Then Warner will expand production. There goes the W. Okay? So that's essentially how you work those problems, okay? Now here's something that's really important that we should put in here, that you shouldn't confuse these statement forms. If I say A if B, right, remember the B goes first because it really means if B then A, right? A only if B, right? And A if and only if B, right? So make sure to not get too confused with these sorts of things, right? And the last thing I want to sort of talk about here is this sort of thing. And this, we're going to see this is what's called De Morgan's rule. But it's just a sort of important feature. And that's the idea that that if I say this statement, Stephen was not fired and Thomas was not fired, right? That means, let's see here, Stephen was not fired and Thomas was not fired, right? It's important to understand that these two things are not the same thing. Right? So actually, let me go like this and actually snip this. Okay. So what I wanted to say here is that, okay, oops. Okay, Stephen was not fired, so let's say it's not S, and Thomas was not fired. That's how I would write that, right? That's one way of writing it. But what's important here is that this is not the same thing as not this S and T, right? These things are not logically equivalent. Why? Now, when I say Stephen was not fired and Thomas was not fired, right, what am I actually saying? I'm really saying that Stephen and Thomas were not fired. Both of them weren't fired. And that's why, well, here, let me read this. Either Stephen was not fired or Thomas was not fired. Because the form statement is not equivalent meaning to this, S is not logically equivalent, right? So, okay, I probably snipped it wrong. But this is translated this, because what does this mean? This means that it is not the case, it's hard for me to say. This means it is not the case that Stephen was fired and Thomas was fired. What does this mean? This means Stephen was not fired and Thomas was not fired, but they're not actually the same thing. They don't actually have the same logical meaning. And this is what's called De Morgan's rule. And we're actually going to spend a whole session talking about De Morgan's rule later on in a later video. So I don't want you to worry about De Morgan's rule too much, but what I want you to do is I want you to be very careful on how you translate these two things because they're not the same. And you're going to find that in the homework, some of them are just downright difficult to do. And the thing is here, remember, the reason we're doing homework is so that you can make your mistakes now. So just try your best, but make sure um, that you really take your time, right? So here's an example here, right? Not both Megan and Kathy are winners, right? So when I say Megan and Kathy are winners, but they're not both that, so that means that both tells me this gets applied to both. But what about this one, for instance? Both Megan and Kathy are not winners. We're going to translate this by saying Megan's not a winner, Kathy's not a winner, and since this both tells me they're conjoined, right? Or there's a conjunction. Okay? Um, Here, this is the textbook. Let me scroll down. So that's the basics of what we need to do in this chapter for symbols and translation. In our next video, we're going to talk about its truth functionality of these things and the truth functions of them. But don't worry about it at this point. I just want you to go through and practice translating statements in your homework with these operators. And you really want to make sure you have the WIFs or you have well-formed formulas here, right? So let's sort of take a look at what your homework asks you to do. The first thing is it asks you to translate the following statements into symbolic forms using capital letters to represent affirmative English statements. How boring it sounds, right? Okay, how do you do this? Cartier does not make cheap watches, right? How would you translate that? Well, probably just by saying not C, right? Cartier makes cheap watches. That's not the case, so it's not C, right? And you're going to find that as you go through these, they get harder and harder. In fact, let's just do a couple of them for you. Okay, so we said this first one, we can just translate this by saying not C. Very simple. This is actually just a simple statement. It's not a compound statement. What is Arizona has a national park, but Nebraska does not. How do I translate this sort of thing? Well, here's where you need to step back and say, well, what's the meaning? What's the takeaway? The takeaway is that Arizona has a national park and Nebraska doesn't. That's what that but really means. And so we're going to translate it like that. We're going to say A and, right? This stands for Arizona has a national park and not N. Nebraska does not have a national park, and that's how that one gets symbolized. What about this one? Either Stanford or Tulane has an architecture school, right? This basically means what? It means Stanford has an architectural school or Tulane has an architectural school. This is going to be S or T, right? So it's not too difficult, at least it's not in those first problems, but you'll see if you scroll down to the bottom, it gets complicated, right? Take this one. It is not the case that either Hezbollah will renounce violence or Al-Qaeda and the Taliban will be defeated. So what you're going to have to do with these, and this is why you want to do the homework, is because as you go through these, they increasingly get more difficult, but you increasingly also become more confident and you'll do better, right? And so you can see they get complicated and you're going to have to use lots of parentheses for this one and brackets. But don't worry, just try your best. And then the ones with the stars actually have the, the ones with the stars actually have the answer in the back of the book. Okay, just go slow and just remember what's the takeaway. You can see the next thing you have to do is translate the following statements to symbolic forms using capital letters to represent English statements. Right, then we'll scroll down here. You can see here, determine which of the following are not well-formed formulas. These are not WIFs. And so let's see if we can spot one right now. This one looks okay. Oh, that's not right. Right, because there's needs to be two. So this is number 2 is not a WIF. It's not well formed. Okay. Okay, and then 6.2 is our next section here on truth functions. So once again, thank you guys for watching the video. I hope this helped. Join us next time for 6.2 and we'll talk about the truth functionality. And ultimately we're going to build up is once you get used to translating these things, we'll then move forward and take a look at how we can actually begin to evaluate arguments and validity. And remember, in order to talk about validity, we have to understand, we have to include the concept of bivalence and truth and falsity. So that's what we're going to be talking about next time. Thanks again for watching. I'll see you guys online next time. All right, bye.